Hello, welcome to my channel Devops with Prasanna. This is day 13 in Learn AWS in 30 Days series. And today we are going to talk about front-end deployment in AWS. So I strongly believe in understanding the fundamental concepts first. And if you have a very good understanding of fundamentals, then you can apply these concepts in any of the hosting provider. It could be Netlify, it could be Vercel, it could be AWS Amplify, like in this case. The tool can change, but the fundamental always remains the same. So this is a structure which I'm planning. First, we are going to see the build process of the front-end tier, and we are going to understand some important concepts in the front-end side, like for example, CSR, SSR, ISR, and things like that. And then we are going to deploy this quiz portal application inside AWS Amplify. And this will have the authentication and things like that. And we are going to see the source code of this quiz application also, so we can understand how the build process is taking place. Yeah, I'm very much excited. Let's get started. Okay, so the build process for front-end tier. These are the steps involved in it could be different tech stack, like it could be Vue.js or Next.js or the React application. It could be like different front-end frameworks, but mostly all the modern JavaScript frameworks follows this structure. So the first one is high-level constructs. So for example, to increase the developer productivity, most of this modern JavaScript frameworks have like a lot of high-level constructs. For example, let's say like this is our application. And this is an open source application. This is a quiz portal which we are going to develop. And this will be the description of this, like the repository URL will be available in the description. So you can check it out. And you can see like there are a lot of JavaScript files here. And this is based out of NextJS framework. But the browsers, they can't understand the Next.js or ES6 or the TypeScript or Tailwind CSS because they are very high level. So someone has to convert this high level constructs into something which a browser can understand. So this is like part of the build process. So someone has to convert this into a plain JavaScript and CSS files. Okay. And the next one is, if I go to this package.json, this is an important file in any of the front-end application. So this is based out of NPM, so Node Package Manager. And you can see two important sections here. One is a script, the other one is the dependencies. So the dependencies specify like what are the libraries we are going to use in this application. So you can see like I'm using Supabase, Next, Post, CSS and all. And which means whenever the build process is taking place, this dependencies has to be downloaded along with this version, and it has to be packaged along with the application itself. Okay, so this is what this section means. And there is something called as linting and static file checking. So this is a concept which you have to understand, like what is meant by linting. So linting means, let's say, you follow certain conventions in your organization. It could be something like for JavaScript, people usually follow camel case convention. So if you name something, it should be like the variable should be having a first word as a small case. All the subsequent words should have the capital case. So that is a convention. If some developer is not following this convention, he should be like there should be some kind of process to check and throw the error for it. So this is where the ESLint is coming into picture. So this is a very popular linting library for frontend. So by default, it has certain conventions. Either we can follow that conventions or we can override that in the ESLint rc.json. Okay. But the thing which you have to understand is all this linting and everything is a static file checking, which means it is useful only till the build process. After the build process, it will not be useful. So which means all these things will come under the dev dependencies because it is not needed for the runtime of the application. It needs needed only in the build time. So we are putting this in the dev dependencies. and this will not be included in the build package. Okay, so that is like one of the steps involved in the build process. So which is linting or static file checking. And the next one is bundling the file together. So maybe like what I'll do is I'll quickly show you what happens when we do the build process. So this is the application. I can run the command npm run build. Maybe like we can quickly see what this command means. So this npm is a tool, and we are saying like invoke this script called build. Okay, that's what this npm run means. And the definition of this script build will be available again in the package.json file. So if you go here in the scripts, there is something called as build. It is simply leveraging the next.js CLI, and then it's calling the build command here, which will do the entire build process. Okay, so we can say npm run build. So you can see some of the outputs here, which is saying like linting and checking for these types. And then it is trying to generate the pages for the source code which we have. There are some certain symbols like 0 and lambda, which we'll discuss later. But finally, it could be able to generate the static assets for us. Okay, so I mean static assets because it is just going to be plain JavaScript, index.html, and files like that. And according to NextJS convention, it will be stored in a folder called .next. Yeah. So if I go into this folder, you can see like there are a lot of files here, which are mostly the meta information about this project. But if I go into this server, you can see there are certain chunks. These are the chunks of our source code. Maybe like just to give you like a basic understanding, you can see there's a component called quiz. And it is having a lot of JavaScript code, which is not in a human readable format, compared to the quiz component which we have here, which is in a human readable format. This is because this high-level construct is getting broken down into a plain JavaScript file, which the browser can understand. So that's what happened here. Cool. Yeah, so this is a step which I want to discuss. Like this bundling together means like taking all the different JavaScript files and then putting all the files into the .next folder in certain convention, which is like very specific to Next.js. But if you think about even other frameworks, like everything follows a similar kind of structure. There is a build process, and at the end of build process, there is some kind of this bundling will happen, and the files will be placed in the like output folder. In our case, the output folder is .next. Okay, and something like all these things will be packaged together, and there is like some sort of minification will also happen. Minification in the sense, like again, like if you see these files here, it has a lot of white spaces because it has to be easily read by the human. But this minification will remove all those things. For example, if I go to certain index.html page, you can see everything is in a single file, and it is very difficult to read by human, but it is sufficient for the computer to understand. And the size of this file will also be like very less. So that is the objective. Cool. So like this is the these are the some of the concepts involved in building the front end tier of the application. But there is like one important point which you have to note, which is the security considerations. See, as we discussed, like there is some kind of bundling happening, and everything is converted into a plain JavaScript and HTML file, which means there are no secrets in front end. Okay, so this is something which you have to understand clearly. You can pass some secrets for any of the hosting provider, but at the end of the day, it is going to be available as a plain text in the application. So, for example, maybe I can show you this. So let's say like we'll take this application. Okay, I'm just logging into this app. And if I go here, this is a network tab. So you can access the network tab using Control Alt I or Command Alt I. Okay. And here you can find different tabs here. So one is the network tab and source tab. Maybe I think I'll look at the source tab. So if you take a look at the source tab, you can see something like underscore next static. So this contains all the static files. Okay. And you can see the chunks are here. This is the same chunks which we saw there, which means you can read the source code. Okay. So if someone has the secret here, that secret will be available as a plain text here. So for example, AWS keys or GitHub token, people can easily take that token and use it for their own purpose. And if I right click this file and say view page source, I can easily view the page source. You can see like what are the text here and what are the tokens here. So it is not advisable to have any kind of secret inside the front-end tier. Okay, so this is something which you have to understand as a DevOps engineer. And all the secrets has to be placed only in the backend. Okay, cool. So this is one thing which I want to show. The next point is, I think like it's about the same point. So anyone can view the source code. So you have to be very much conscious about what you're going to put in the front-end tier. And the last one which I want to talk about is code obfuscation. So because everything is visible in the front end, like no one should like unless and otherwise like it's an open source project, no one should be able to take the source code and use it for their own purpose. Even if it's an open source project, there are some licenses to be followed. But this is to avoid people taking the source code. So what we are going to do is we are going to do some kind of code obfuscation. So code obfuscation in the sense, if you see this variables here, you can't understand what is the meaning of this variable because it is R, N, and then there is like there are some variables which are fine, but most of the like application side variables, it will be obfuscated. So if you see there is a function called M, and the variables or the arguments for this function is like some random characters, which is very difficult for anyone to understand. Okay, this is made intentionally because the code should not be readily available to anyone. Okay, so that is the purpose. Maybe like just because we are here, I'll just touch upon one more topic. So like whenever you are going to create some application, you should always keep readability in mind. So for example, like when you are naming a function, you should never name a function as like A, B, or N, which will not have any meaning at all. You should always try to give a good meaningful name. Like for example, here it is called compute result. Okay. The importance of this thing is like this code should be readable by another human. So code obfuscation is only for hackers and other players, not for your code developers. Okay. So always try to have a naming complete good naming convention. Okay. Cool. So now we have looked at the build process. So these are the various steps involved, and this is what happening at the build time, which means like this is happening well ahead of like a person is requesting for the page or something like that. So it's called as build time. Okay. Let's say like the build process is complete and all the assets are deployed into the server. The server can be anything. It could be, in our case, it's going to be AWS Amplify, but it can be Vercel, it can be Netlify or anything. Okay. And all the other things happens at the runtime. Runtime in the sense when there is a new user coming to your website, he'll be like typing your like DNS name, and that will send a request to the server, and server will send the information. Okay, so this is going to happen like this. So based on like how the page is getting rendered in the sense when a user requests for a page, like how that page is painted in this browser. Okay, that is called as rendering. So based on this rendering, like there are different types or different concepts which you have to understand. Okay, I'll not go in depth into all these concepts, but I'll touch upon at a very high level. So the single page application. So before a single page application, This is what happened with the frameworks like Ruby on Rails or PHP and things like that. So for example, like when your browser asks for some page, this request will be sent to server, and the server will be sending the full HTML page. Okay, it is not just the JavaScript or CSS alone, but it's a completely rendered page that will be sent to the browser, and browser will just show the page. Okay, that's how things work. So for each and every request, there is going to be a HTML page as a response. The problem there is it's very slow, and there is no clear separation between server and the client, meaning like the front end and back end. Okay. So there is some kind of templating which is used, and mostly the backend code will also contain the templates for front end as well. So that's how the things were. The SPA changed many things, because what can happen is client can have its own framework like NextJS or React.js or whatever it is, and the front end team is completely isolated from the backend team. So backend can be in Ruby on Rails, but it can just expose a API, and the front end can be in Next.js. Okay. So this is like a clear separation between front end and back end. That is one advantage. The other advantage is when at the start time in the single page application, only the empty index.html page is given. And all the content are getting replaced in the same HTML page. Okay, that's why it's called single page application. There is like only one page. But all the different pages you are seeing, it's just the dynamic content which are getting painted using the JavaScript itself. Okay, so it was like very fast because there is less amount of data being transferred from the server, and like these are the advantages of SPA. Okay, but there are like it has its own disadvantage as also. So we are going to see all those things later. And mostly like this client-side rendering and SPA is a similar concept. Okay, so and the next concept is server-side rendering. So this is in the olden days only server-side rendering was there with the Ruby on Rails or other frameworks. But now we can have the power to combine CSR and SSR. Okay, the next one is static site generation. The other one is incremental site regeneration. So we are going to see all these concepts in detail. Okay, the first one is client-side rendering. So you can see like this is a format which I'm going to follow. Like there's a build process, that's a server side, and then there's a client side. And we'll try to understand different concepts using this three point of view. So the build process is completing all the HTML, CSS, and JS. In the server side, like for example, whenever a client requests for a page, like or the client visits the website, first an empty index.html is sent, and then the client will request for the JavaScript, and the JavaScript will be sent back to the client, and that JavaScript in turn can request for other JavaScripts or the data from the server, and similarly it will request for CSS, and CSS will be sent back to the client. So that's how the rendering of page is going to be. So this is an example of SPA, single page application. But the problem here is, for example, if you have if you want your website to be search engine optimized, that is slightly difficult, because when Google tries to crawl this page, initially it will see only the empty index.html page, which means there is no content in it, and which means Google will think it's an empty page, and it's not SEO optimized. So that is a problem. But apart from that, it's a very fast, because once the JavaScript is loaded, it is just going to be the data that is going to be like sent back from the server, and all the rendering will happen in the client side itself. So the network latency is like very, very less. Okay, and to make this point, like Next.js supports CSR, SSR, SST, and ISR as well. So we'll just see the example with Next.js. Okay. But because it's going to be like a developer side of things, I'm not going to focus much on the coding aspects. Okay, we'll focus only on the DevOps side of things. So the next one is server-side rendering. This is also something which we already saw. So after build process, all the static assets are there in the server. when client requests for the first page, the index.html page is sent. But this time, it is not an empty page. It is a page with the actual content itself. And if client requests for some other page, it will send the request to the server, and server will create the content. So you have to understand this difference. So it'll talk to database or talk to other servers, and then it'll get the content, and then it'll create the page, and then it'll send the page to back to the browser. Okay, so that's how like this server-side rendering is going to happen, and this is going to use something called as server-side props in the Next.js. Okay. Yeah. So the next concept to know is static site generation. This is very useful in case of the blog websites. For example, like like not even blog, any content management system. For example, just to understand like why it is very useful. If you take the example of WordPress and other sites, it is very slow. The reason for slowness is whenever the client requests for a page, the request will be sent to server, and server will like query the database or do things like that, and then it will get the content, and then it will send the content back to the client, which means there is a processing which is done by server, and that's why like it is very slow. But in case of static site generation, all the pages are built at the build time itself. So you can see there is a slight difference between the server-side rendering and the static site generation. In the server-side rendering, it will only create the HTML, CSS, and JavaScript. There is no actual content being generated in the server-side rendering. But in the static site generation, all the data are fetched and the actual pages are built. Okay, this is not just a plain JavaScript or things like that. These are actual pages, and these pages will be stored in the server side. So whenever a client requests for the page will be sent back immediately. There is no processing which will be done by the server. So this is like very fast, right? Like a client requests for page, it will get back the page. So the processing is totally eliminated, which means like they are like really fast. But the one problem here is this can't be applied to websites for which the content is getting frequently changed. For example, in case of like Twitter or something like that, like your feed page will always be different whenever you refresh the page. So we can't statically generate the site at the build time itself. Okay. But in case of CMS, like the content management system, the content pretty much remains the same. For example, even for blog, like you will write blog, like let's say like one blog per day or things like that, which means like we should be able to regenerate those pieces alone, and whatever remains static, it can remain static. Okay. So this is a evolution of static site generation, which is called incremental site regeneration. So again, it's going to follow the same mechanism. Like it will build all the pages at the build time itself, and then the pages will be sent to server side. But one catch is the build happens at a regular interval. So in case of the Next.js, we'll use get static props. Static props, if you use this method, then Next.js will think that this is going to be a static page. So it will create the page at the build time itself. But if you can give it with a validate period, so this component alone will get rendered at that validation period. So for example, it can be 60 seconds or 1 hour or period like that. So for that time period, like the pages will be built again and again, and it will be sent to the server. So this is called incremental site regeneration. Maybe I think like this is a good time to show you like show you how this happens in the like build process. For example, if I say npm run build, yeah, so you can see something like this here, 0 and then lambda. So if it means 0, it is called static page. If it's lambda, it's called server side rendered page. Okay. So what this means is like for all this routes /home /login /result, Next.js is smart enough to identify like it need not compile the page again. Okay. All these pages can be statically generated at build time, and it can give the page back to the browser in a very fast manner. Maybe we'll just take a look at this result and we'll understand like why it's happening that way. So if I go to result.js, you can see like there is no API call being made or nothing is being done. It is completely a static page. Okay, so because like this is I'm in process of creating this site. So like I gave all the information as a static placeholder. So there is like nothing which is going to change based on time. So even if I access the same page again tomorrow, it's going to have the same content. So Next.js is smart enough to identify like this is a static page. And that's the reason like it gave the symbol as this. And similarly, like it has some kind of server page also. For example, this hello, which is a backend API call. Okay, cool. So I think like this is what we should know at a very high level about the client-side rendering and the static site generation and things like that. Cool. Okay. So now we are coming to the actual AWS service, which is Amplify. So Amplify is a very good service if you want to deploy your mobile application or web application. In fact, like Amplify is very good for hosting the full stack apps as well. Full stack in the sense, if you want some kind of data to be stored, data modeling, and then if you want to have some kind of backend server authentication, even like if you want to create your own design and integrate with Amplify, that is also possible. So Amplify has very good integration with Figma as well. Okay. So this is the power of Amplify, and definitely it can't be explained within 15-20 minutes. But just to give you like how Amplify is working, like it'll just act like an orchestrator, which means if you store some data, it will create the actual tables in DynamoDB and store the data there. Similarly for other services also, for other services available here, it will just create the service and it will use the service. And all the creation happens via the CloudFormation template. CloudFormation is the infrastructure as code for AWS. So, meaning like whenever we create Amplify apps, we can see the CloudFormation in action, and it will create all the resources for us. So coming to Amplify, like there are two ways in which you can use Amplify. One is the studio mode or the hosting mode. So studio mode is for creating the apps, and the hosting mode is for it's for hosting your application. Okay. So in this session, like we are going to talk about the hosting side of things and how it will use leverage CloudFront to host our quiz application. But if time permits, we'll go into the studio side of things as well. And there is one point to be noted, like Amplify has Gen 2 with a very good developer experience with sandbox environment and things like that. So if you are interested in learning about that, please let me know in the comments. That will involve both the DevOps side of things and developer side of things as well. Just like it's tightly coupled to both sides. So if you are interested, please let me know. I'll do a separate video for that. Cool. So this is the intro about Amplify, and this is a demo which we are going to see. So we are going to deploy the quiz portal, and that quiz portal is available in GitHub. So we are going to connect Amplify to GitHub, which means there is some kind of auto deployment will happen. Like whenever I push a commit to GitHub repository master branch, it will get deployed into the Amplify. We are going to define the build steps, like how the build happens. When I say build, what are the steps involved? And then we are going to add some env variables so that the authentication and things like that will work. And then we are going to deploy the app in the Amplify. And then we are going to attach a domain and then use a CloudFront to do all the traffic. So if you search for Amplify, then you can land in AWS Amplify page. So this is the home page for Amplify. And we are going to create apps here. So I'll go to all apps. Okay. So there are two modes as we discussed. One is Amplify Studio, the other one is Amplify Hosting. So this is to build app, this is to just host your app. So you have to know the difference. So I'm going to just host my app here. And it's asking for my the source code. So the source code will be in GitHub. Cool. So GitHub authorization was successful because I've already connected my GitHub to Amplify. But you can do the same. You'll just ask for your username and password, and then your like approval. So I've given approval for quiz from Prasanna app, and the branch it's going to be master. Cool. So if you remember, like this is a second step where we want to specify our build commands. But Amplify is very smart enough to know that this repository which I connected, it is a NextJS repository, which means it knows like what are the build artifacts. For example, for the front end, the pre-build command is yarn install, which is to install all the dependencies. And then the build command is yarn run build. So if you remember, like previously we used npm in our local, but here it's yarn. Yarn stands for yet another resource negotiator. So that is also a very good tool to either install your dependencies or package your node application. The good part about yarn is it's very much compatible with npm. So in places where you can use npm, you can directly substitute yarn for that. Like there is no change in it, which means the repository which we have, either we can build it using npm or we can build it using yarn as well. And the artifacts. So it's going to use this .next as a base directory because that's where all our static assets are going to get into. And it will use all the files. And it will use a cache also. So cool. So this is a build step which it's going to follow. And in the advanced settings, I'm going to give my environment variables. I'm going to use this environment variables mainly because for authentication. So if you remember, like we used the GitHub authentication, and that is powered by Supabase. So I'm going to give the Supabase credentials here. So what I'll do is I'll stop, I'll pause the sharing, and then I'll come again. Okay, so I've given the details, and this is my app settings. Also, you can see the framework is Next.js SSR, which is a server-side rendering. So I'll do a save and deploy. And to know about the keys, like I've created a file called env.template. So here you can substitute your Supabase URL and Supabase on key. And if you want to know about Supabase, please let me know. Like I'll try to create a video for Supabase authentication and how we set up this folder. Yeah, but coming back to this one, you can see the quiz from Prasanna app is getting ready. It is getting provisioned. It will do a build. It will create the assets, and then it will do a deployment also. Okay, like when we are here, I just want to quickly show you like how things are set up. So this is using GitHub as an authentication provider. So if I go to settings, developer settings, I can see my apps here. So one app is quiz from Prasanna. And here, like I've generated a client secrets. So this will be a ID and secret key. This is what I've used in Supabase. So if I go to Supabase authentication, there is a tab for authentication. And here you can see I have the URL configuration. So this is going to be my URL. I'm going to change this to quiz.easyinfrared. And then if you go to providers, you can see I've enabled the GitHub provider. And here I've given the client ID and secret, which I got from my GitHub. And similarly, this authorization callback URL, it's coming from this authorization callback URL. So this is a Supabase callback URL. Okay, so cool. So this is how I've configured the things. And this seems to be good. So you can see like the build is also complete. If I click on this one, you can see the build process. So it's running the command called next build. And then you can see the similar results here. Like some of the pages are static pages, some are server pages. And then all the things are complete. Cool. So deployment is also complete, which means we got an Amplify app URL. And if I click this URL, you can see like it's directing to our page. But things will not work because we authorize only few domains to go via the GitHub authorization provider. So what we'll do is we'll try to add that as well. If I go to this app, you can see like we can add a custom domain with free SSL certificate. So I'll go here, I'll add a domain. I'll say my domain is quiz.easyinfra.dev. So it's saying like quiz and then www.quiz. Both will be like deployed from the master branch latest code. And Amplify can manage the SSL certificates for me. Cool. This will take some time. But this is a similar kind of setup which we did already in AWS S3 and CloudFront sessions. Again, like Amplify is going to use CloudFront in the backend to create all the things for us. And for this SSL configuration to work fine, like Amplify should know like we are the owner of this domain. So to do this, we're going to copy the CNAME record into my domain hosting service, which is GoDaddy. So I'll add a new record here. So this will take some time, and then it will validate the SSL configuration. Then we'll add the domain also. Okay, the SSL configuration is valid now. We need to activate the domain. So to activate the domain, we'll say view DNS records, and we can get the CloudFront domain. So we'll add this to the GoDaddy. So if we go to it, add record, it's going to be a CNAME. And again, like if you want to understand what is a CNAME and other things, you can check this link. We have discussed this in detail in the CloudFront and the S3 sessions. Okay, cool. So this got added. Now if we go here, in some time, the domain activation will happen. Okay, so if I refresh this page, it's still saying that domain activation is in progress, but I could able to access this app. So if I go to quiz, so you can see like quiz.easyinfra.dev, it is accessible. And if I try to log in, it will say like authorize quiz from Prasanna, and then I could able to authorize. And you can see this is a Supabase URL. So it will use Supabase and it will do the authorization. So cool, we could able to get into our application. This is a dummy application, which is a static site generated page, which we're going to fill up in the next section. But we could able to deploy our front-end application. Okay, cool. The deployment has succeeded. It is shown here. Before wrapping up, I just want to show few things of the Amplify. Like how Amplify is different from other services like CloudFront or S3 bucket, like hosting a site using S3 bucket. So you can see like one important benefit is Amplify has a way to do a continuous deployment. So whenever I push code, all the things will the changes will be automatically deployed to Amplify application from the GitHub repository. Apart from that, there are a few other things as well, which is the first one which I want to show is the preview environment. So for example, if I create a new branch and I can add commit to that branch, and if I open a pull request, which means Amplify will create a new domain for me. which will be of just format pr1amplifyapp.com. I can visit this domain and see my changes in the live. This is one thing. And we can easily enable the notification. So when the build passes or fails, we can easily get the alerts via the SMS. And the next one is this monitoring. So for example, we can see like how many requests are being sent, how many requests are errors, 500s, and things like that. So this is like a very useful information for us. And apart from that, the most important thing is the Amplify Studio settings. So till now, we used Amplify as a hosting environment only, but we can use Amplify to have it like a studio type of environment where we can create the backend, we can create the UI component using Figma, and we can do many other things as well, like user management and things like that. So this is called Amplify Studio. Okay, I think like we reached the end of session. I hope you had a very good information about Amplify. Yeah, happy learning. Bye-bye.